All right, so I want to go over some very simple properties of logs and how they apply to solving log equations. So remember, whenever you have a log, the only way that you can get rid of a log is if you change it to the exponential form. That's the only way you can get rid of a log. This is always the base, the exponent, and what it equals. That's the only way you can ever get rid of a log. That's if you have the log of, if you just have one log. Sometimes you guys are going to have two different logs. You're going to have a log on the left side, and you're going to have a log on the right side of the equation. So let me kind of just explain this concept to you. Let's say I say log of 5 times a number is equal to the log of 3 times that same number plus 12. So technically, this is saying that 10 raised to something equals 5 times a number. And this is saying this exact value is the exact same thing as 10 raised to something equals 3 times this exact same number plus 12. Conceptually, these two values are the same if we knew what x was and if we knew what it was raised to. So if you understand this concept, then technically these logs are gone. And these values are just exactly the same. So this value right here, 5x, because 10 raised to some number equals 10 raised to the exact same number to give us this same value. So technically, this value has to equal this value. Then if you were to solve this, you just subtract 3x from both sides to get 2x equals 12, x equals 6. Well, let's see if this actually works. Let's plug in a 6 into here. So 5 times 6, which is log of 30, equals, let's see if this works here. 3 times 6 is 18, plus 12 is 30. Both of these work. Both of these values are equal to 6. The x has to equal 6. So just a shortcut. Whenever you have the log of two values, and you just have one log and one log, nothing else. Get rid of the logs and set these two values equal to each other. Okay, I'm going to do a couple example questions now. The first example question that I'm going to do is, let's say we have log 3x minus 2 equals log of x plus 1. You have to solve for x. Well, based off of what I just did, you should be able to just set these two equal to each other. 3x minus 2 equals x plus 1. Subtract x to get 2x, add 2 to get 3. X equals 3 halves. Okay, that should have been pretty simple. Let's try the second one. Let's try this second. I'm going to go ahead and write this, and I want you to pause the video and try it yourself. This is from the notes. Log of 5x plus log of 3x equals log of 45. Pause the video and see if you can solve this on your own. Okay, let's see how you did. So you can't get rid of all three of these logs and say 5x plus 3x equals 45. That doesn't work. You have to use properties of logs. So if you have log, when you add, it's the same thing as multiplying the two values, giving you log 15 x squared equals log 45. Now that you have a log on both sides, and it says on the notes, if you have the log on both sides, you can technically just cancel this out and say 15x squared equals 45. Divide both by 15 to get x squared equals 3. Then when you square root this, something that happens. So what I'm going to do is I'm going to get my calculator and I'm going to go ahead and square root this. So the square root of 3 is equal to 1.73. But this is the thing. It's a plus and a minus 1.73. This is technically the answer, but you cannot have a negative log as the answer. One of these answers is extraneous. How do you know which one is extraneous? If you plug this positive 1.73, you won't get a negative log. But if you plug a negative 1.73 into here or into here, you're going to get a negative log. So therefore, the only answer is a positive 1.73. Okay. Next. It says, when you have, you can also solve by using basic algebra to solve for a single log. So let's start off with one of the examples that I give you. I say 2 log 3 x minus 4 equals 48. Now, technically, if you were to get conceptual, doing this a hard way, this becomes an exponent to get log 3 x minus 4 squared equals 48. And then if you set this up, this is base, exponent, what it equals. X minus 4 squared is x squared minus 8x plus 16. 3 to the 48th is going to be a huge number. Move that over a quadratic equation, but this way sucks. Sucks. The good thing is, I'm going to rewrite this equation back right here. 2 log base 3 x minus 4 equals 48. So look, you understand that this is 2 times this value. Technically, I can divide everything by 2. Boom, and that goes away. Therefore, I have log base 3 x minus 4 equals 24. Now, what I can do is 3 to the 24th power equals x minus 4. And if I were to solve this, I would just add 4 without doing this. I've never been, I don't know, let me try this on a calculator. 3 raised to the 24th, you're going to get a scientific notation answer. So you would just do this. You would just add 4 to get x equals 3 to the 24th plus 4. That's your answer right there. That's pretty simple. Another example, when they give you an equation that you can solve with algebra, is the next one, where I say you have negative 5 plus log 4x equals negative 25. Let's see if you can solve this. Try and solve this. Actually, what I'm going to do is this. I'm going to change this because this is going to give me a huge number just like this. I'm going to change this and make this a -5. I'm going to get rid of the -25, just make it a 5. So I'm going to say -5. Let me get rid of all of this right here and say -5. Just for the sake of solving this, to the 4x equals -5. Pause the video and see if you can solve this. Okay, first thing you should have done algebraically is add 5 to both sides to get log 4 times x equals 0. Then, how do you get rid of a log? You rewrite it in exponential form. Base, which is 10, exponent, and what it equals. Giving me 1 equals 4x and x equals positive 1/4. Boom, done. Logs, you can use just basic properties to solve. Solve for super, super simple equations. Okay, now let's get to some more logs. We can use properties of logs, the very last thing on the notes, we can use properties of logs to get a single log on both sides. Look at the first example that I do. I have log base 9 x plus 6 minus log base 9 x equals log base 9 2. All right. Now when I'm doing this, I'm going to combine. I'm going to say log base 9. Remember, when you subtract, this is your numerator. This is your denominator. Equals log base 9 x. Oh, wait. Sorry. Log base 9 2. Okay. Now, what I'm going to do is I am noticing that both of these logs have the same base. So this value, x plus 6 over x, has to equal 2. The way you figure out what that number is, multiply both sides by x to get, boom, to get x plus 6 equals 2x minus x to get x equals 6. Okay, well, let's see if this is our answer. I have no idea, well, I do, but I have no idea. Let's say I have no idea if this is my answer. So what I'm going to do is I am going to plug in 6 into here, a 6 into here, and see if I get 2 as an answer. All right, so I'm going to have log base 9, 6 plus 6 is 12, minus log base 9, 6. You might say, wait, 12 minus 6 is 6. It's not 2. This is not correct. Well, you're wrong, because remember, when you subtract, it's the same thing as taking your positive log, dividing it by your negative log. 12 divided by 6 is log 2 of base 9. This becomes a 2 of base 9. That's it. There's the first example. All right, let's try the next example. Okay, for the next example, I have natural log. I have x minus 3 minus natural log of x minus 5. So I have natural log of x minus 3 over x minus 5 equals natural log of 5. All right. Well, let's see if you know how to solve this. First thing that I'm going to do is I'm going to cancel out these values because I know that x minus 3 over x minus 5 has to equal 5. Okay, how do I solve? Well, let's turn this into a proportion and cross multiply. X minus 3 times 1 is x minus 3. 5 times x minus 5 is 5x minus 25, because I'm multiplying both of these. And then solve for x. We're going to add 3 to get negative 22. Minus 5x to get negative 4x. Divide by negative 4. Your answer is going to be 11 over 2. Simplify because I divide by negative 4. To get x equals 22 over 4 is 11 halves. Or 5.5. Now if I plug, let's try it, see if it works. Let's plug a 5.5 into the original equation. So I'm going to say natural log of 5.5 minus 3 minus natural log of 5.5 minus 5. Let's see if I get natural log of 5 as an answer. I'm going to use my calculator. 5.5 minus 3 divided. So I'm going to get natural log of 2.5 minus natural log of 0.5, and then if I were to go 2.5 divided by 0.5, I'm going to have natural log of 5, because remember, whenever you subtract, it's the same thing as dividing this by this. Okay, let's try the very last one. Natural log of 2 minus natural log of 3x plus 2 equals 1. This one might be a little more difficult, and I am going to leave this for a second for you to try it. Pause the video and let's see how far you get. All right, since you paused it, you should have all gave it a shot, so let's see. I'm going to change this natural log. I'm going to use the quotient property. When I subtract, I know that this is my numerator. This is my denominator. So this is where I'm at so far. Now what I got to do is this. I have to change this into exponential form. So my base is e to the first equals 2 over 3x plus 2. All right. I'm going to put this over 1, and I'm going to solve for my x. So I'm going to say 2 times 1 is 2 equals 3x times e is 3xe. E times 2 is a positive 2e. All right, now I have to solve for my x. I have to isolate to get x all by itself. First thing I can do is I can 2 equals, I can factor out an e from both terms to get 3x plus 2. I actually went backwards on this, but whatever, it's fine. Now what I'm going to do is I'm going to divide both sides by e to get rid of the e, giving me 3x plus 2 equals 2 over e. Next step, subtract 2 minus 2, and then divide by 3. So my x equals, you can leave it just like this, 2 over e minus 2 over 3. And then that's it.